Okay, so I'm continuing my series of every exam question that has ever been asked, and we're going to have a look at inequalities now. Now, if you want to use this document, it is linked in the description and it is fully hyperlinked. Now, I'm going to do both linear and quadratic. There's a lot more quadratic than there is linear, but let's just see how it all goes. Okay, so to begin with, we're going to just solve this inequality that we have here. It's really just like solving an equation, but making sure you keep that sign in the middle. So the first thing I'm going to do is take away that 11n from both sides, which will leave me with a 3n and the 6, and then I'm just going to divide by 3 on both sides so that I get that n is greater than 2, and you can't just write 2, you have to write that n is greater than 2. It then says on the number line below, show the set of values of x for which x plus 3 is in between -2 and 4. Well, because they want us to do it for x, we're going to actually have to solve this equation, which means I'm going to take away 3 from the middle part, which means I also need to take away 3 from here, and I need to take away 3 from here. So I'm actually showing that x is between -5 and 1. Now this symbol has, I always say this symbol goes with the empty circle and this one goes with the filled in circle, because this one uses less ink than this one does. This one gets more ink, so it would be a filled in circle. So at -5 you draw an empty circle, and at 1 you're going to draw a circle that we fill in, and then simply we just connect those two things together to represent the inequality -5 and 1. So let's just double check that we've got these right. We've got that n is greater than 2 and between -5 and 1, with those bits not filled in and then filled in. This time we just want to write down the inequality on this number line. Now you'll see there's the letter x here, but they would accept it with other letters, but we're going to use the letter x, and we're going to say that x is greater than -1, because it's all of the values that are bigger than -1. The other way that you might see this is you could say that x is greater than -1, or -1 is less than x. So either of those things would be accepted. So for this one, I'm going to do, for this symbol, it's going to be a filled in circle at -3, and it's going to be an empty circle at 4, and we're just going to connect them together like this. So there we've got our x is greater than -1 and between -3 and 4, just like we had on the previous part. So now we've moved on from the linear ones, and we're going to start thinking about the quadratic inequalities. Well, what we do for the quadratic inequalities is we kind of solve them if they were equal to 0, and then we'll reason what's going on with this part afterwards. So the first thing I want to do is try and factorize this that we've got here. Now you could use the AC method where you multiply these parts together, but if the coefficient at the beginning is 2x, we actually know that there's going to be a 2x for one of them, and the other one is going to have to be an x. And we also know that if it's multiplying to -2, that they're going to have to be a 2 and a 1, with one of them being minus. So let's just experiment with which different ways it could be. Well, if I had a +2 over here, and a -1 over here, I would get 4x minus x, which would give me the 3x. So I've definitely got this part right. So I'm going to find out what my critical values are. My critical values, also known as the roots, from this first one that we've got, x would be equal to 1/2 when that bracket is equal to 0. And from the second bracket that we've got here, this is when x would be equal to -2. So if we draw a quick sketch, and it literally is just a sketch of some quadratic, doesn't need to be done accurately at all, -2 is one of the roots, and the other root over here is at 1/2. And we're trying to say, when is this quadratic graph greater than 0? So this part is above the 0 line for y, and this part is also above the 0 line. So the x values that it corresponds to are these ones that are along the bottom. And so what I mean by that is, for this first section, these values of x are going to be less than -2. So we get x is less than -2, and our other inequality is when these values of x apply, which is when x is greater than 1/2. So let's double check this. Great, x is less than -2 or greater than 1/2. Okay, this time we've got a pair of inequalities, and it says that n is an integer such that both of these are true. Find all the possible values of n. Well, this one's linear, and this one's going to be quadratic. Let's start off with a 3n plus 2 is greater than 14. So 3n plus 2, is less than or equal to 14. So I'm going to subtract 2, and then I'm going to divide by 3, so I get that n has to be less than 4. Now let's deal with this next one. Now that n plus 5 is going to multiply up to the other side, and that's actually okay for us to do, because I don't know if you remember, but you're not meant to multiply inequalities by negatives, because it can flip it negative or positive. Sorry, if it's a negative, it flips the inequality sign around. But I know that n squared plus 5 is definitely a positive number because when you square something you get a positive. So we don't need to be worried about multiplying this n squared plus 5 up to the other side. That gives us that 6n is greater than 1 multiplied by n squared plus 5, which is just n squared plus 5. So we're going to still make it look like a quadratic. So we're going to have our n squared minus 6n plus 5, and we're going to find our critical values of it being equal to. So if it was going to be equal to 0, I need to think of two things that multiply to 5, but add to minus 6. So I think those things that are going to multiply to 5 are going to have to be a minus 1 and a minus 5, because they will still add to minus 6. So the critical values are going to be, from the first bracket, 1, and from the second bracket, 5. So when we draw a sketch of what this is going to look like, we want it to be crossing on two positive parts at 1 and at 5. And this time we're saying, when is the quadratic less than 0? So the quadratic is less than 0 here. In other words, when n is between 1 and 5. And you'll notice the inequality symbol doesn't have the or equal to. So when we say that it's between 1 and 5, we will say it like this. So the things that we need to be true, I'm just going to do a little box here. It needs to be that n is less than or equal to 4, and n has got to be between 1 and 5. So these would apply to 4, 3, 2, 1, etc. And these ones would just be 2, 3, and 4, because the 1 and the 5 can't be included. So the numbers that are in both of these are literally just going to be 2, 3, and 4. That's the only one that satisfies both of these things that we've got here. Let's double check that we've got this right. Yep, it's just 2, 3, and 4, and we had to do those two inequalities together. Okay, this time we have got a slightly different kind of quadratic. It looks a bit unusual. Now I'm going to think about trying to solve this starting off all as one inequality, and then I might need to break it down. So first of all, I'm going to get rid of this divide by 4 by multiplying everything by 4. Now 22 multiplied by 4 is 88. I'm then going to get my m squared plus 7, and then 32 times by 4, that's going to be 128. Obviously you can do this on a calculator because it's a calculator paper. Now I'm going to subtract 7. So I'm going to say that it's 81 m squared and then 121. Now when I take the square root of these, I'm going to be thinking that I could get a positive and a negative square root. So let's just start off by taking the positive square root. If I take the positive square root, I get that 9m and 11. Now when I take the negative square root, we're just going to need to be really careful about the way that we write our inequality signs. So we've got our minus 9, we would have our minus 11, and we would have our m. But it doesn't make sense if I say this, because this is saying that m has got to be bigger than minus 9, but less than minus 11. So when I write those inequality signs, it's going to be the other way around, like this. So we've got these two answers that we've got here, and it should make sense, because if m is in between 9 and 11, let's say 10, then m squared is between 81 and 121. And if m was, say, between minus 9 and minus 11, like minus 10, when you do m squared, you would still get 100, which is in between these things that we've got here. So both of these together are our answers that we've got. So kind of not like the traditional way you'd think about doing a quadratic inequality. And probably you'd get this one, but you might not have thought about this one at the bottom if you take the negative as well. And so you can see we've got both of these solutions here, and they've just got them written the other way around, but it is identical to what we've got there. Okay, in this one, you might think I'm going to have to do some expanding of the brackets to try and solve this, but actually we've only got one x by itself, so we could just square root both sides. That's going to give us the critical values, and then we're going to use the critical values to try and reason what the inequalities should actually be as the final answer. So when I take the square root of both sides, I'm going to get that 1 minus x is less than the square root of 9 over 25. Well, remember you can just do the square root, and actually I'm going to just pretend this is like an equals to. We're going to do the square root of this. You could do it on the calculator, but this is just going to be the square root of 9 over the square root of 25, which is 3/5. Remember, it could be plus or minus because we've just done a square root there. So I'm going to solve both of these equations. One of the equations I'm going to solve is this one, that 1 minus x is 3/5. So I'm going to add the x to the other side, so that I get 1 equals 3/5 plus x, and I'll subtract 3/5. Remember, you can do all this on the calculator if you need to, so that x is 2/5. The other one I'm going to solve is that 1 minus x is minus 3/5. So I'll put the x on the other side, and then I'll add the 3/5, and 1 plus 3/5, that's 5/5 plus 3/5, which is 8/5. So these aren't actually going to be the answers to the inequality, but they are going to be something to do with our critical values that we've got. Now, if we think about this original one, about what it would look like when we expanded the brackets, it would start with well, let's just expand the brackets and show you. There would be a 1 minus 2x plus x squared. Now, the important thing that I'm looking for there is that it's a plus x squared, which means when you draw the quadratic, it's going to be that shape and not that shape that we've got there. So if I was going to reason with what we have, if I was going to draw this, I'm going to be thinking about a value that looks like this kind of shape. And although we're saying that it's less than 9/25, we can still say it's the less than part of the graph, because we have found the critical values, and I've not drawn that central bit very well because it's 2/5 and 8/5. So if we have 2/5 and 8/5, we are looking for when the quadratic is less than the value, which still means it's going to be the below part of these bits. So for this below part that we've got here, we're looking that x is between 2/5 and 8/5. So I'm going to say that x is between 2/5 and 8/5. And of course, you could give that as a decimal. You could say 0.4 and 1.6. Either of those things would be perfectly accepted for this. So you could try it out. You could substitute in values and think about how that might actually affect if it's going to be less than 9/25, if you're not sure about which way to do these inequality signs. So we do have the 2/5 and 1 3/5. It says OE, which means or equivalent, and you can see that they've got 1.6 and 0.4 as alternatives as well. Okay, so this time it's a non-calculator one, and it says, here is a rectangle and a right-angled triangle. All the measurements are in centimetres. The area of the rectangle is greater than the area of the triangle. Okay, so we know that the area of this rectangle is going to be 3x minus 2 multiplied by x minus 1. So I'll do the 3x times x, that's 3x squared. And then I'm going to have the 3x times minus 1, that's minus 3x. The minus 2 times x, which is minus 2x. And the minus 2 times minus 1, which is plus 2. So the area of the rectangle is greater than the area of the triangle. Okay, so my area of the rectangle is 3x squared minus 5x plus 2, and that's going to be greater than the area of the triangle. Let's work out the area of the triangle. The area of the triangle is going to be the base multiplied by the height divided by 2. And x times 2x is 2x squared, and 2x squared divided by 2 is x squared. So I can now actually see that I've got a quadratic inequality here, that the area of the rectangle is greater than the area of the triangle. Just like any kind of normal quadratic, I'm going to make this become one where it's 0 on one side that we've got here. We didn't do it on the other one. The reason we didn't do it on this previous question that we had is because we had just 1x by itself. But if you don't have 1x by itself, we want it to always be greater than or equal to 0, something like that. So now I'm going to try and factorise this bit that we've got here. Now, you could do the AC method or the MAM method, but actually I think we can probably just figure out what this is going to be straight away, because I know that the beginning bracket has got to be something to do with a 2x and an x. And there's only so many options you can do if there's a plus 2. It's either going to be a plus 2 and a plus 1, or a minus 1 and a minus 2. So just think about which way round that's going to be that will give us minus 5x. Well, I'm going to put the minus 2 here, which would give me minus 4x. And I'm going to put a minus 1 here, which would give me minus 1x. So that's minus 4x minus 5x. Now, if you don't like the way that I've done that there, that's absolutely fine. You can just do whichever method you prefer. Now, I'm going to say that it's equal to 0, because I'm going to be looking for my critical values that we've got. And my critical values from the first bracket is going to be a half. That's when it's equal to 0. And from the second bracket, it's 2. That's when that is equal to 0. So now I'm going to draw a sketch, and literally just a very simple sketch where I've got that this is, put it on this side, that's a half, and that is 2. And we're trying to say that it needs to be greater than 0. So if it's greater than 0, it's this branch, which is that x is greater than 2, or this branch, which is that x is less than a half. Now we need to check both of these to see if they make sense, because can x be less than a half, or even can x be equal to a half? Well, no, because if you have a half minus 1, a half minus 1 gives you a negative. So I'm going to say here, but x has to be greater than 0 as it is a length. So we can't have that x is less than half, so our solution is just that x is greater than 2. So we can't have this one down here because of the fact that one of the lengths will be that one subtracting 1. Let's double check we've got this one right. It is just that x is greater than 2, and they only want that one. You wouldn't be allowed it if you gave the other one as well. Now this one I think is probably the hardest one here because it actually blends some stuff to do with exact trig values. So if you don't have your exact trig values, you might find this a bit trickier. Oh, actually it's a calculator paper, so it doesn't really matter how we want to do this one. So there's a couple of different ways you could do this. You could either try and find the height of this parallelogram, because we know that the area of a parallelogram is the base times the height. Or what you could do is imagine this being cut in two pieces like this so that you've got some triangles. Now if you've got some triangles here, I could find out the area of this triangle and I could double it because these triangles' area are the same as each other. So I think we could do that. I think we could say that the area of this parallelogram, well, there's two of these triangles, so there's two triangles, and one of the triangles, using our half AB sine C, we can say that it's a half times 10 minus x times 2x minus 1 times the sine of 150. So to begin with, this 2 and this half are going to cancel out because 2 times a half is 1. So all I'm going to do here is I'm just going to work out the sine of 150 and see what we get. And the sine of 150 is a half. So this means that it's going to be a half multiplied by these brackets expanded. So 10 times 2x, that's 20x. 10 times minus 1, that's minus 10. Minus x times 2x, that's minus 2x squared. And minus x times minus 1 is plus x. So let's just keep going with this. Let's simplify what we've got inside the brackets here. We have got a half brackets, 20x plus x, that's 21x. And then we have minus 10 minus 2x squared. And it says that the area of this parallelogram is greater than 15 centimeters squared. So I'm now going to say that a half 21x minus 10 minus 2x squared is greater than 15. Now I'm going to just get rid of this a half by doubling everything so that I get 21x minus 10 minus 2x squared is greater than 30. Now I want the 2x squared to be positive, so I'm going to put it all onto this other side that we've got. So I'm going to say that there's going to be a 2x squared, then I'm going to subtract the 21x, and then I'm going to do the 30 plus the 10, which is 40. And this inequality that we've got here, where the quadratic is less than 0, we've got that the quadratic is less than 0 in this particular part, so we can stop there. Now part B actually wants us to find the range of possible values of x, so it means we're going to kind of continue from what we've done on the other side. Now I'm going to rewrite it so that I've got my 20x squared minus 21x plus 40 is less than 0. Now I'm going to do my AC method. My AC in this case, I'm just going to quickly block out a bit here so that I've got some space. The AC that I've got is the 2 times 40, which is 80. So I'm trying to think of two numbers which multiply to 80 but add to minus 21. Well, it could be 10 times 8, but that's going to give me 18. What about in the 5 times table? 5 times 16. So if they were both negative, I think that's going to work. So that means I can rewrite the middle part as 2x squared minus 16x minus 5x plus 40. And I'm just saying it's critical values, so I can say it's equal to 0. Then I'm going to factorize the beginning bit, so that's 2x, because that's the highest common factor of just these two parts that we've got here. That's going to be 2x brackets x minus 8. And then I need the second bracket to have an x minus 8 as well. So it looks like it's going to be a minus 5. Yeah, the minus 5x, and then the minus 5 times minus 8 gives 40. Which means when we factorize this, it is 2x minus 5 and x minus 8. And so the critical values, in other words, when it's equal to 0, are going to be 8 and 5 over 2, or 2.5. So what we need to do now is think about what this would look like on a quadratic. So it's going to be a 2.5 or a 5 over 2 and 8. And we want it to be less than 0. Less than 0 is this part here. So it's going to be that in-between section that we've got. Now, actually, I think both of these are going to be valid. So let's just write down what we think it's going to be. I'll write it as 2.5, x and 8. Let's just double check they both make sense. So if I do 10 take away 2.5, that's a positive length. And if I do 10 take away 8, that's also a positive length. If I times them both by 2 and subtract 1, they're going to be positive. So I think my answer is going to be that x is between 2.5 and 8. Yep, 2.5 and 8 that we've got here. Now that's everything that there is on quadratic inequalities. That last one was a bit sneaky because it blended this in as well. But generally, if I'm not sure where to put a topic, I put it in what I think sort of the more challenging thing is, so that if you're looking at quadratic inequalities, you've hopefully come across a half AB sine C. If you found this helpful, please do like the video, share it with some friends, and make sure you subscribe to my channel, because not only do I have these exam questions, sort of like walkthroughs, but I've also got things that will actually teach you these things in a bit more depth and detail, rather than me just sort of telling you how to do these questions in these sort of one-off sort of things. So good luck with your revision, and I hope it all goes well for you.